Okay. So once again, yesterday, at the end of class, I kept on telling you, you got to divide, you got to divide, you got to divide. Remember remainder theorem, plug it in, get a number. Plug it in, get a number. Plug it in, get a number. Today, we're going to look at a situation where I tell you to factor, but I don't give the factor to you. Let me say that one more time. Up until now, anytime you had to factor or you had to do some kind of division, I gave you what you needed to divide. Ooh, I don't need that. Does that make sense? Take a look. Every time I ask you to divide something, and that is, let's say, like here, right? I said, hey, here is a factor of f of x. I always gave you something to try. And if it works, and you get a remainder of 0, yay, 0, you can even go further by sketching. Today's lesson, there's a whole bunch of theorems, but don't overcomplicate it. Today's lesson is, what if I don't give you something to factor? You have to figure it out yourself. What? How do we figure out whether it was a factor or not? What told me that it was a factor? If you plug something in and the answer was a 0, you know that it was a factor. So does that mean if you have to figure it out yourself, does that mean you have to do what I think you have to do? How would you discover a factor if I didn't tell you what it was? No? Well, you could try and error, but that's going to be really hard. Using remainder theorem, what could you do to figure out if something is a factor or not? Yes. Not put in a 0, but you're looking for a 0. You start plugging in numbers until you get a 0. So long story short, if I ended today's lesson right now, and I said, hey, get out of my face, go factor that. What would you have to do? You would have to plug in every number you know in hopes that you get a 0. Does that sound like a smart method? Henceforth, we get this thing called integral or factor theorem and integral 0 theorem. Take a look at today's sheet. As a reminder, let me get this part 10 thing set up. As a reminder, I am going to use a couple of things just to make our lesson easier. P of x is my polynomial. When I talk about the remainder, I'll just call it r. And these two are going to be my divisors, which we can technically call d of x. All right, just ways to make life easy for us. Okay. So using our remainder theorem, we already talked about this. Maybe someone can tell me in their own words. This is the textbook definition, the factor theorem. This ax minus b binomial is a factor of p of x if and only if this is true. Can someone tell me in their own words what that means? It's basically an extension of what we did here and here. What does this mean? This bracket is a factor of the function if, only if, that equals 0. What am I trying to say? Plug in the root. You take this factor. If you plug in the root of that bracket and happens to equal 0, you found that perfect factor for you. You can divide perfectly. That's what it means. Pretty complicated for something that you already know, huh? This bracket is a factor if the root gives me a 0. So let's test it. as a way to snowball towards our next theorem, could you please then, using the factor theorem, can you confirm if any of these factor this part nicely? Tell me if any of these is a factor of that. What would you do? Let's say that was the quiz question. Is x minus 2 a factor of polynomial? The easier method is, okay, test. Let's zoom in a little bit. It's easier to see. Test. If x minus 2 is my factor, I am going to test x equals 2. So let's plug it in. I don't have much space, but p at 2 is 2 times 3 cubed plus 3 times 3 squared minus 3 times 3 minus 2. 3, 27 plus 54. 3, 9, 27 minus 9 minus 2. I am not even going to try to figure that out. All I care about is whether it's 0 or not. So without wasting time, can you see that's not going to be a 0? Yeah? Keep moving. Yes?
I thought we're doing b divided by a.
Well, what is b divided by a? Isn't it just 2 divided by 1?
Yeah.
So I'm plugging in that 2.
Oh, yeah, you plugged it in.
I'm crazy. I was just making sure you're awake. Sorry about that. I don't know why I did that. That is 2 cubed plus 3 times 2 squared minus 3 times 2. Let's just say it's been a long week, yeah, for both of us. 2, 4, 8 times 2 is 16. 2, 4 times 2 is 12. Minus 6 minus 2. And it should have rung a bell because I've done this sheet this morning. I don't know why it didn't ring a bell. Anyways, again, I don't care about the answer. All I know is it's not a 0. I am no longer interested. So you move on. So therefore, x minus 2 is not a factor. Try the next one. X plus 2, that means the root is negative 2. What is f at negative 2? We have, because I don't have much space, I'm just going to calculate it. Negative 2, negative 2, negative 2, negative 8 times 2, negative 16. Negative 2 times a 3, that's 12. Negative 2 times negative 3, that's a positive 6. And minus 2. Positive 18. Negative 18. 0. Yay. Therefore, x plus 2 is a factor. At that point, you can stop and go and log division, go and synthetic division. Because you found a factor. But anyways, the whole point of today's lesson is, what if I don't give it to you? Do you really have to trial and error every number possible until you find a 0? The answer is yes, but not really. There is a shortcut to figure out what number to find first. Yay. Introducing integral 0. Here's a short lesson. I mean, you can finish this if you want to, and I think my answer key online already has this filled up. But here's a quick lesson. Do you remember when you were doing factoring in grade 10, you had, let's say, x squared plus 4x plus 3. How did you know to use these numbers?
Because 3 and 1 at 4.
Okay, so you looked at you looked at that, right?
Yeah.
That's you, by the way. Yeah, okay. Kidding. That's gross. You're not gross. My drawing is gross, okay? In the same way, consider this, x squared plus something crazy, 16x 18 minus 36. Yeah. And let me do the factoring for you. it turns into plus 18, x minus 2. How did I get 18 and how did I get 2?
Product sum.
Of, where was your attention first going? If I asked you to factor.
The second and third term.
Second and third term. The product always starting here. In the same way, if you want a factor for cubic, for quartic, for quintic, for everything, you are going to look at the last number. The factors of your polynomial will coincide with the factors of the constant. Introducing the integral zero theorem. And up to here is essentially what you might need for your quiz, okay? Not the back page. If I have a factor, notice how there's no a value, just one x minus b. If this is a factor for a polynomial with a leading coefficient of 1, and all the other ones are equal, then I know that this b is also a factor of the constant term of p. I'll say that one more time. If I have a factor, let's highlight that. Okay? If the factor I'm talking about is indeed true for a polynomial with a leading coefficient of 1 and all the other coefficients are integers, then the number that I am looking for, the b value, is also a factor of negative. What do I mean by that? I'll demonstrate. Give me the numbers that multiply to negative 8, including plus and minus. So one person, yeah?
Negative 4 and 2.
More. So start with the easiest number.
Negative 8.
Plus minus 1, which will get you the plus minus 8. And plus minus 2, which gives you plus minus 4. I like to go outside in like that so that I know I'm not missing any factors. Integral zero theorem tells me that if I want to look for the factors, I'm not trying every number. All I have to do is try those 8. And cross your fingers. Let's hope it works when you try a 1 or a negative 1, because those numbers are easy. But sometimes you might have to go to 2 or higher. Yes. Yes. I'll erase that because we did factorial, right? Yeah, sorry. B is a factor of 8. So let's try it. Which one of these would be our factor? Let's test. F at 1. So that is 1 cubed plus 3 times 1 squared minus 6 times 1 minus 8. I already know that's not a 0. I don't want it. So x minus 1 is not a factor. You're running out of space here, so I am going to try it again. Okay, what's the next number? Next easiest number. Negative 1. I'm going to test it. Negative 1. That is negative 1 times negative 1 times negative 1. Negative 1. Negative 1 times negative 1 times 3. Negative 1 times negative 6. And negative 8. Ooh. Positive 9. Negative 9. It equals 0. Therefore, x plus 1 is a factor. Yep.
You see the down to the factor.
A definition of a factor is a number that divides into another perfectly. So for example, let's say I have 10. Do you remember in elementary school you had to do like this? Do you remember that? Or you know, and then yet another one, and you could do 2 times 5.
All factors.
1 and 10 are factors of 10. 2 and 5 are factors of 10. A factor is basically what multiplies into that other number. Become that other number. That's it. X plus 1 can multiply with something else to give me this, is what I'm saying. Let's do it. If you have a factor, what did we do yesterday? I asked you to quickly divide. And so you can fully factor. So if you want to try this by yourself, you can. I will demonstrate it just in case. 1, 3, -6, -8. And my root is -1. Here we go. 1 down. Multiply. Add. Multiply. Add. Multiply. And yay, we confirmed it. Take a look. Our remainder is a 0 with a happy face. Yes? Do until you're comfortable. You only need 1 to start. And let me demonstrate. So the question was, when do you know when to stop testing for numbers? If you found 1, we're pretty good. Take a look at what happens. Now that I use synthetic division, the function x cubed plus blah, blah, blah becomes x plus 1, and this, -8, 2x, and x squared. 8, 2x, x squared. So this part goes there, and 2 goes there, and x goes there. And why do I say go until you're comfortable? You could continue if you'd like, but because I've practiced enough in grade 10 and 11, I can figure this out. Continue factoring, because the question says factor fully. There. Find the remainder of 0, we can factor, and by consequence, we can sketch. That's the final bit. We are testing a bunch of plus minus numbers, aka integers. We're testing integers until we get a 0. Integral 0. So if I give you an equation or a function and I say, hey, go fully factor, exactly what you test. Look at the last number, keep going until you get a 0. Question? You might want to test your metal. Give it a shot. Example 3, that's on you. You know where to look, right? Try it. What are factors of -18? And then perform. Maybe I'll pause this video a little bit. All right, let's try this. Assuming you gave it an honest shot, what are the factors of -18? Plus minus 1, plus minus 2, plus minus 3, and that gives me plus minus 18, plus minus 9, and plus minus 6. Is there any number in between? No. So I have 6. So I'm going to test the easiest numbers first, plus or minus 1, plus or minus 2. F of positive 1. 1 plus 2 minus 9 minus, I know that's not going to be a 0. F at -1. -1 plus 2 plus 9, yeah, and that's definitely not going to be a 0. F at 2. 8 plus 8 minus 18 minus 18, that's definitely not a 0. F at -2, -8, positive 8, positive 18 minus 18, yay, that's going to be a 0. So x plus 2 works. Yep.
On a test, I just read like -1 and like doesn't equal 0 for
Yep.
tests.
Yep. You can. So I'm doing it. I'm showing my work. But if you know that it's not, just write.
Does that mean that the x for that term exists, so you just
Skip it or just add a 0 as a coefficient. Or both is okay. Typically, people just don't write it. It's a waste of time. 1 times -2, there. 0 times -2, 0. Add times -2, 18. And just as suspected, it is 0 remainder. What does that mean? That means f of x is x plus 2 minus 9, 0x, and then x squared. Hey, I can go further. I've done my difference of squares. X, 3, 3, plus, minus. There you go. The final piece of the puzzle. Oops. Uh-oh. What did I do? Oops. Okay. The final piece of the puzzle would be, or if you're following this and you're having an okay time with it, the next question would be, well, we've done questions where the a value is always a 1. What if it's not? Just like quadratic. What if it's not? Right? Up until now, it was always a 1. Do you remember if it was like this? Some funky stuff had to be done, decomposition and whatnot. In the same breath, you're going to see something called a rational zero theorem. Before it was integral zero theorem, we plugged in integers to find the 0. What do you think rational zero theorem is inputting? Ratios, aka fractions. We were like, what? Yeah. Remember I told you about my teacher? All factors that you had to test were fractions. Not very nice. Would I do that to you? Probably not. Okay, but again, expect the worst, hope for the best. Here is how you go about testing numbers if the a value is not 1. Question?
yes, sorry. I've heard you mention before that we will need to know if this.
Yeah. If I give you a question like this where you have to factor with no help, always be a 1. Just okay. Yes.
You factor or
For the quiz, I don't think I would do that to you. Yeah, of course. Yeah. Just factor that, let's say for here, factor a 3 out. Just work with this, and whatever your answer is, use multiplying at the end. Okay, so let's do this. You can read this, but for the sake of time, because I want you to have a break too, consider this. What are the factors of this? Yep. No, right now, just -24. So just like the integral zero theorem, look at the last number. This will be either 1 and 24 or 2 and 12 or 3 and 8. Oh, sorry. Yeah, 3 and 8, 4 and 6. Ooh, that's a lot. What are the factors of 3? One and 3. Rational zero theorem. If ax minus a b is a factor of a polynomial that doesn't have a 1. B is a factor of negative 24, and A is a factor of 3. So the numbers that you have to test are 1, 2, 3, 4, 6, 8, 12, and 24 over 1. As well as 1, 2, 3, 4, 6, 8, 12, 24 over 3. You have to test every combination. So can you imagine if I gave you a factor for a value that has like 4 or 6 or 8 different possibilities? That would be rude. So you cross your fingers and you pray that 1 or negative 1 works, and 2 and negative 2 works. Okay? What's nice is that here, 24 over 3, that's 8. That's actually right here. 12 over 3, that's 4. We already tested it. 6 over 3, that's a 2. We already tested it. And 3 over 3 is a 1. I already tested it. So it doesn't add too many extras, but it is still a possibility. So you go ahead and test it. Please note, that's something that you can try for the last, I guess, 5 minutes that we have. You please put 3 stars here, or 3 little exclamation marks, to tell yourself that if 1 over 3, if f of, let's say, 4 over 3 works, or 4 over 3 equals 0, the factor is not x minus 4 over 3. The factor is 3x minus 4. Do you understand? Factors are not written as a fraction when we normally factor, like polynomials. It's always written as a binomial. Okay, so once again, why don't you try it? I think like 2 or negative 2 might work. I forget. Maybe 3's work. But you don't have to go that big before you find one. Think. Give it a shot. Example 5, same idea. I'm not going to go through it, but I will ask you to try it for homework along with whatever textbook questions I ask. For your quiz, once again, it is going to be mainly focused on long division synthetic. Let me turn this a little bit. Long division synthetic, remainder theorem, in other words, plugging it in to find a 0 or another number. And if I ask you to find your own factor, it will be just that. No fractions, just integral 0.
For no rational?
No, I'm not going to get you to test fractions in there. No.
What's questionable, like the question to test where it's like x cubed minus ax squared on k.
I don't know. Yeah, I don't remember, but it's a very good question. Better safe. Yeah. Those kind of questions really show whether you understand the concept or not. So practice those. Yes. The extent of graphing I would expect from you is like this question. You know how I gave you something that's factorable? And using x-intercept, you could be able to do NGA. Yeah. If I give you a graphing question. And one thing I forgot, did I add it here? Oh, that would have been bad. Do you remember a long time ago when we were practicing factoring, I showed you cubic sum and cubic difference? And I said, it's not on the test, it's gonna be on the next quiz. I'm going to give you no word questions. I'm just going to give you cubic sum difference of cubes, okay? Know how to use. I'm just gonna give you a number question. Here's something cube plus something cube factor. And you also get your formula sheet, and that is right there. It's on your formula sheet. So all you have to know is how to use this formula. Okay?